All right, so let's review for a second here. So something we've already talked about, guys, is how to find roots by factoring. So what I've done is we've looked at quadratic functions that look like this, right? And I asked you guys to find the roots. Now, roots are where it touches the x-axis. And when it touches the x-axis, you plug 0 in for y. And the way that we solved the quadratics we learned was by factoring. Now, for this, you would use the box method. I'm not showing my work for that. I'm just giving you what you would get as a result of doing the box method. And then we did the zero product property, which is where you set each factor equal to 0 and solve. And that tells us where it touches the x-axis. So this one would be touching the x-axis at 1 and at 3. Probably looks something like that. So wait a second in case you guys are still writing. Yeah. Where'd the 1 come from? Factoring this using the box method. I didn't show my work for that. I just kind of skipped that for this review, but for now, that's probably good enough. All right, and so as we said, guys, to get from here to here, we do the box method. But not all polynomials can be factored, so not all quadratics can be factored. Okay, so I'll give you guys an example of one here. Like if I were to give you this, x squared plus 3x plus 1 equals 0. If I asked you guys to do the box method on that, you're not going to get an answer out of it. You would put the x squared here, you would put the 1 here, and there's only one way to get x squared and 1, but these numbers here can never add up to make that middle number. So not all polynomials can be factored. Some of them are unfactorable, which means they're also called prime when you can't factor them. But that doesn't mean that they don't touch the x-axis. And so we need another way to find the roots when they can't be factored. And that's what we're learning today. Is we're learning another way to find roots without factoring, just a different strategy. Okay. And so that's what our whole topic for today is, guys. Is just using this other way to find the roots where it touches the x-axis. Now the benefit to this method is that it always works. I could give you any quadratic equation and it will always tell you the roots, whether it's factorable or not. This strategy that we're going to learn today will work on it. So that almost makes the factoring strategy unnecessary. except for the fact that factoring is useful for a lot of other things. And also, I personally find it easier. This method we're using today has a lot of like calculation involved, and so it's kind of tedious. But it does always work. So the benefit is it always works. The downside is a lot of calculation to do. So there's a pro and a con to it. So here we go, part C. How can we find the roots of a quadratic without factoring? That's our question. So here we go. If ax squared plus bx plus c equals 0, someone came up with a formula, and you guys have seen it before, I'm pretty sure of it, but it looks like this. That's called the quadratic formula. So some things to take note of. The quadratic formula will work if you have a standard form. It's got to be standard form. It can't be the vertex form. Standard form, and it also has to be equal to 0. Okay, so if it's not equal to 0, you can't use it. Now, if you ever have a quadratic that's not equal to 0, you just have to move some numbers around so it does equal 0, and then you can use it. But it does have to equal 0 before you can start using it. Okay, because it's a formula that's designed to find the roots, and that's when the thing is equal to 0. All right. So this is kind of a hard thing to memorize. Some people have learned it with Pop Goes the Weasel. I'll sing it for you, and it goes x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Who's heard that before? No? No? Oh my gosh! So it works really good with Pop Goes the Weasel. So you could do that. I've also heard people say memorize it with a story. And so it goes like this. It says, there once was a bad boy, negative b, bad boy. And he couldn't decide, plus or minus, he couldn't decide if he wanted to go to the radical party, because he thought he was squared. He was square. Like, and I don't know if you guys, have you ever heard the thing like, that guy's square? That's like an old term for saying somebody's kind of a nerd. So I don't know if you guys are familiar with that terminology, but because he was square and it was missing 4 awesome chicks. 4 awesome chicks. Sorry for the sexist terminology. It's just to help you memorize things. 4 awesome chicks. And it would be over at 2 a.m. past his curfew. So there's a bad boy who can decide if he wanted to go to a radical party because he thought he was too square and was missing 4 awesome chicks, and it'd be over 2 a.m. So you could do that to help memorize the formula if you want to. Or you can just do it the old school way, put it on a flashcard. But it's a good formula to know, very useful. It's one of those things that you'll use. I'm sure you used it in Algebra 1. You're using it this year. You'll use it again next year. You'll use it in calculus or pre-calculus, wherever you go. This is a very useful formula, so it's worth memorizing and taking the time on it. So now that we are familiar with it, let's go ahead and use it to find some roots now. Now that formula, like I said, it works for factorable ones. And by the way, you guys can see the answers here. These are all the problems that we're going to do today. You see these ones that look like nice normal numbers here, like -1 and -2/3. Those are problems that you can solve by factoring. So the first the first two problems we're going to do today, technically we could solve it by factoring. But I just want to show you the quadratic formula works on those also. Quadratic, but these ones here with these weird square roots on them, factoring won't do it. It's impossible, so you have to use the quadratic formula for those. So let's go ahead and begin. All right, so go ahead and call this example 1, and we'll say solve using quadratic formula. All right, and then go ahead and write down the problem. I'll wait for you. Okay, so two things have to be in place in order to use quadratic formula. It has to be standard form, which it is, and it has to be equal to 0, which it is. So we're good for quadratic formula. What we want to do is want to start off by identifying our A value, our B value, and our C value. The A is the one that's in front of the x squared. So my A value on this one is -3. My B value is the one in front of x, so that's the one with a -5. My C value is the one that doesn't have an x, so that would be -2. Okay, so we want to make sure that we start by identifying our A, B, and C. I'll number these steps just to kind of add some structure to our work for today. Now, whenever I do these things, I like to start by writing out my formula, but with just blanks and parentheses instead, okay? So, there once was a bad boy who couldn't decide if he wanted to go to the radical party because he thought he was too square, and it was missing 4 awesome chicks, and it was over at 2 a.m. All right, so the first two blanks is about the bad boy. That's the B. So I'm going to be putting the B in those first two blanks. So we have -5 and -5. The next blank, 4 awesome chicks. So that's an A and that's a C. So the A is -3 and the C is -2. And the party was over at 2 a.m. So this is 2A. So we want the A down here. So -2. Huh? Oh, thank you. Thank you. That's right. Okay. So that's the next thing you do. The next thing we're going to do is we're going to start simplifying this thing. Now, everything we're about ready to do is just a whole bunch of adding, subtracting, multiplying, dividing, but it's just, there's a lot of it, and you have to do it in the right order and stuff. So here we go. My first suggestion would be to take care of this guy. What does that simplify to? +5. And then this guy, 25. Bring down the minus. And then we'll simplify this group. What does that become? 24, yeah. So 4 times -3 is -12. Times -2 is a +24. And then this guy. So I like to start with those 4 groups that I've circled up there. And on your notes, I would encourage you to circle those 4 groups as well, just so you know which ones we did. Yeah.
When you're doing that step, you just keep the -4.
Yeah. Okay. So that's a that's a good question. So Yeah, you can. But her question was, instead of thinking of this as a minus, can we think of that as part of the 4? You can. I think you'll be okay if you do that. It'll work out. I like to just think of it as a minus, but you can. All right. Let's go ahead and continue on. The next thing we're going to do is we're going to take care of this. So let's circle this. And we're going to do that off to the side. So what is 25 minus 4? Well, we're going to do the subtraction first. So 25 take away 4 is 1. And what's the square root of 1? All right, so that's nice. By the way, when you have a nice square root like this, that means that this problem could have been solved by factoring. If it's a nice square root, we actually could have solved this by factoring instead. But it doesn't matter because this will still work. So we're going to finish with what we started here. So we just found out that whole thing equals 1. Okay. At this point, for this problem, I would say it's probably going to be helpful to split it up into 2 problems. I'm running out of space, so I got to delete some stuff. All right, so for part E, notice how it's plus and minus, right? So I'm going to write 2 equations. I'm going to do x is equal to 5 plus 1 over negative 6, and x is equal to 5 minus 1 over negative 6. And there's one of my roots. For here, I'm going to reduce and get 2/3. All right, so there's your process. I do it in about 5 steps, basically. And once again, on your notes, I would encourage you guys to circle these things like I did, just to kind of indicate what pieces I simplified as I went to the next step. Because it's kind of overwhelming. There's a lot of calculation going on in there. And if you follow that process, you'll get there. You'll get there. But if you start doing things in a wrong order, it might mess you up. I'm going to bring up a student practice here for you. Here it is up here at the top. I'm leaving my work up here so that you guys can finish writing if you're still writing. But I would like you guys to start that problem there. Go ahead and start that with the quadratic formula. Go look at your very first step and tell me what goes in the first blank here. Next blank. Cool. Next blank. And next blank. And bottom. Great. All right, so that's what your second step should have looked like. So step 1's here, step 2's here. Let's go ahead and take a look at step 3 here. So you should have gotten 7 there. 49 here. Bring down your negative. And 48 there. And 8 there. Oh, I wrote the wrong number there, though. 49. Now, the square root of 49 minus 48 is the square root of 1, which once again is 1. That's not very creative. That's the same thing I had. It won't always be 1. It could be other numbers, right? Matter of fact, that's what our next set of problems are going to look like. But after you do your square root, you get 1. Kimaya, I know you were not quite there yet, but what's the last step? What do we have to do last? I have right now 7 plus or minus 1 over 8. So what's our last step to do?
You did step B already, right?
Oh yeah. So we did A, B, C, D, and we're on E now. Mm-hmm.
You do it again, but it'll be 7 this one.
Good.
Over 8.
Good. So you're basically going to split up into two. You're going to do 7 plus 1 over 8 and 7 minus 1 over 8. And this one is going to give you 8 over 8, which is 1. And this one's going to give us 6 over 8, which is 3/4. And those are the places where it would touch the x-axis. Okay. We're going to erase that, so if you want to take a picture of it or something, feel free. I'll pause for that. All right, we're going to do number 3 here. So go ahead and write down number 3, please. All right, let's begin. This time I'm going to have you guys walk me through a lot of it just because most of it, there's not new stuff. Most of it's just kind of the same. When we get to the square root part, things will get a little different. So Denise, for step 1, or step A, I should say, what's my A value? What's my B value?
1.
Good. So notice there's no number in front of the R there, so that means it's a 1, so we'll put a 1 there. And then C value?
-12.
Good. All right, I want you guys to go ahead and plug it in real quick. And I'll call on someone to fill in the blanks for me. So fill in these blanks. And I'll pause for a second, let you fill those in. So there's your fill in. Now we're going to go and have you guys do part C here, and I'll call on you to simplify that for me. So go ahead and do part C. I'll give you a little second to work it out. All right. So Brittany, what am I going to replace that with? And then here, I'll bring down my minus. How about that? Good. Now notice we have double negatives there, you guys, right? So we have the minus, which comes from the formula, and then those 3 numbers multiply together to make a negative. So we have a minus a negative, which you guys know that means it's going to do something. And the bottom here is what? Okay. So what happens, guys, when we have double negatives here? Yeah, it's just positive. Now, we're going to step off to the side here and we're going to do this. Now, what we'll usually do at this point is we'll try to break down. This is not a nice square root. You don't have a nice just, oh, the square root of 97 is something good. It's something where you have to break it down and take out the pairs. But 97, I'm pretty sure that's a prime number. Okay? So, let's write a little note here. Actually, I'll write that note in a second. Let's go ahead and move on to the next step, and then I'll write the note. And we're actually done. Okay? So if the square root doesn't simplify, that's the note I was going to write. If the square root doesn't simplify, we're done here.
But what about the other x?
The other x?
Are they both equal to the same thing?
That's a good question. Thanks for asking that. I'll answer that in a second. Let me give people a chance to write it. There's still 2 answers here. So Denise was asking, what about the other x? So first of all, a parabola or a quadratic equation, it can have 2 roots. Let me draw a picture for you. It can have 2 roots. You don't have to draw this though. It can have 1 root. Or it can have no roots. So it's possible to get no solution. But this one actually still has 2 answers to it. It's just that the answer is really ugly and we can't really tell what it is. Now what we could do is we can get out a calculator and we can find out what the square root of 97 is and kind of round it a little bit and get an estimated answer. But we still have 2 answers. And I think on your multiple choice quiz, they will write them separately like this. I don't see any reason to do this, but I'll do it because your quiz will be written that way. But there you guys go. So you can write it as 2 separate answers, but there are still 2 separate answers. So once again, get out a calculator, -1 plus the square root of 97, whatever that is, divided by 4, and you'll get some decimally answer that you round off. Same thing with the second one. Okay, so we'll stop there. But yeah, you can get 1 answer, 2 answers, or no answers. It's possible. I'm going to do one more with you. I'll go through it a little bit quicker, so keep up with me on the notes. The reason I'm going to go through it a little bit quicker is because 90% of it's old news. We already know how to do it. There's just this one little piece I want to make sure we talk about. There's actually 2 parts that are kind of useful. I'll slow down when we get there. Is anybody needing that still? If you want to take a picture of it or something, you can. I'm going to move on here in a sec. Okay. Let's go ahead and take a look at Go ahead and write down number 5 here. Number 5. Once again, I'm going to go through it a little bit quicker, so keep up with me on the notes here. So my A is -7, my B is -8, my C is -6. The next thing we're going to do is we're going to plug in those numbers, right, to find our roots. So we have, I like to start off with the blanks first. My B value is -8, my A value is -7, and my C value is -6. So we have 8 plus or minus 64, and this is going to end up being minus, I don't know, I got to use a calculator. 4 times 7 times 6. I'm going to subtract those, and then I'll wait a little bit to give you guys a chance to catch up with me, but once again, I can't wait too long, so go ahead and catch up with me. Brianna, what happens when there's a negative inside of the square root? Not sure? Okay. Someone want to take a crack at it when there's a negative in the square root? You get an I. You get an imaginary number. So I'm going to put an I out here and do that. So that's one thing you want to watch out for. Now, just so you guys know, this means there are no roots. You might want to write that little note down. This means there are no real roots. In other words, this quadratic function, if you were to graph it, it would not touch the x-axis. I see a lot of busy hands with phones or nothing at all. You guys should be taking notes with me here right now. You're missing notes that you need at all. Start writing. All right, so this means there are no real roots. It won't actually touch the x-axis. You don't need to draw this, but maybe it would look something like that. It would not touch the x-axis. Now we're still going to find the answer, but they're what we call imaginary roots. Okay. All right. So at this point, we're going to break this up. So we're going to split it up like we have in the past. 2 goes into 104 52 times. 2 goes into 52 twice. 2 goes into 26 13 times. So this broke up, and this broke up, and I'm left with these 4 numbers here. All right, so we have I square root 2, 2, 2, 13. So, Niana, do you remember what to do at this point? Yep, we got a pair, right? So for every pair, you can write that number on the outside and drop the pair. And so what I'm left with here is 26. So that's the first big difference about this problem that I want to point out. Sometimes you got to break down your roots. Sometimes you get imaginary numbers. And what that means is that there are no real roots. So let's continue. So we have 8 plus or minus 2i root 6. Now here's another slight little difference that I'd like to point out with this problem. And this is probably something worth writing down. If these 3 numbers can be reduced together, then we should. I'll show you. We need to reduce. So, is there anything that divides into 8, 2, and 14? 2. So, if there is, then we need to reduce that out. Okay? So, we're going to divide all 3 of those numbers by 2. So 8 divided by 2 is 4. 2 divided by 2 is 1i, so I'll just put i. And then negative 14 divided by 2 is negative 7.
How do you do that?
It's like reducing a fraction. Mm-hmm.
So is it really like 26?
Oh yes, thank you. This is supposed to be 26, you guys, not 6. All right, another little note that's worth writing down here is a lot of times on your multiple choice test that you guys have, they won't leave the negative on the bottom. What they'll do is they'll move it up to the top. So I'll just put move negative to the top. So if you ever have a negative on the bottom, you need to move it up to the top. So here's what the final answer here would look like. I'm not going to write it as 2 separate answers this time. I'm just going to write it as a plus and a minus. But there it is. So there's a lot of interesting things. There's 3 big things I want you guys to know. So first of all, square roots, if they don't simplify nicely, it's okay. Just simplify them like we always have. Second of all, you might need to reduce. You might, if you have all 3. Only if it's all 3, though. It can't be just 2 of them. If you have a number here, here, and here, and they all have something in common to reduce out, then you can do that. And then finally, move your negative up to the top, if you have one. There's not always a negative on the bottom, but if you have one. All right.